Okay, so let's continue. Yes, you can see my screen. This is just the the possible combination to minimize the clogging talk. Clogging talk is a talk that unwanted, which is bad talk, unwanted. Just now we have a power, then we have electromagnetic talk, right? Talk actually is a power lah. But inside this talk, it has a good talk and also bad talk. Good talk and the bad talk. The talk that we want, the talk that we don't want. This clogging talk is the talk that we don't want. It is something like when we put a magnet, together, north and north pole. For example, when we push it together, so it will have some energy to push together, right? Then this is one of the forces lah. This is only one of the forces. In order to interrelated to the clogging top is something like when we have a north pole and this is the stator teeth. Okay, when in this position, maybe this is the optimum position, whereby it will sustain like this. If let's say we try to put a north pole like this, okay, and then it cannot sustain this position for that moment because it has a force align try to align the field try to align the field it become which become uh, like this. uh, then this kind of forces we call clogging torque, unwanted clogging torque in a simple way is explanation. The formal explanation is the interaction between the rotor pole and the stator. The interaction, for example, the interaction here, it cannot stay for even 1 second because they have a magnetic line, and then they will like to try to align it become like this so that the line can be go like this. Uh, so some of the research found that okay, the slot pole ratio can give the minimum torque like this. For example, 1.125. Then the 98 should be the minimum one. Then 36 and 32 is the minimum one. If let's say the rest one should be higher for the top. Huh? So overlapping winding machine, like for example, 16 slot and 6 pole. So 16 divided by 6 is a 3. Number of slot per pole is a 3, and SPP is 3, which is more than 1.5. 3 means 1 tooth, 2 tooth, 3 tooth. Tooth. This one is 3. Same as well. Red to red, right? So 1 tooth, 1 teeth, 2 teeth, 3 teeth. Say the tooth, teeth. So overlapping, you see, if let's say the orange color is winding like this, then the red color at the bottom winding like this. So partially is a overlap here. You see, this one is overlap. This part is overlap. Then this one, the orange overlap with a green, something like this. As long as overlap, then we call overlapping. Non-overlapping, this one is non-overlapping. The winding is here, and then the winding is here, here, here. It is not overlap at all. For example, uh, this is one winding, this is one winding, this is one winding. It is not like I wind to here, then I wind from here to here. So this part is overlapping. Right? Okay. Finish this slide. So I will go to the winding layout. We will start from simple one. Let's have a look. Okay, maybe I need to put it like this. Okay. So when we want to start we call design the winding layout. First of all, this is the calculation step, and you need to memorize. This is the calculation step. For example, 3 slot 2 pole PM machine. First of all, we need to convert the electrical to in between electrical and mechanical by using pole pair. No matter omega or theta, it can be omega, it can be theta. So in here we use a theta. So theta E is actually mechanical degree times a pole pair. So I think I want to remind you again, in the motor, we are dealing with geometry, geometry, which is we have two things. One is a space, okay? One is a space where this is 0 degree, 90 degree, then 180, and then 270, then 360, all in mechanical degree. But the problem is we still need to relate with the electrical degree. So when we want to relate electrical degree, usually it is in a time, voltage, ampere, something like this, or flux, B. So how to do that is we need to have a connection between the electrical degree and mechanical degree, where the electrical degree is actually mechanical degree times pole pair, rotor pole pair. So this is a 3-slot 2-pole machine. 1 slot, 2 slot, 3 slot. How many pole? 1 pole, 2 pole. Okay, so this is a 2-pole machine. So how is the calculation? So remember this one, step 1. We need to calculate the slot pitch. Slot pitch is, and then calculate the MMF vector for a coil. So I'm not sure you still remember MMF or not. Magneto, motive, force. It is a force generated by the movement of the magnetic field. F. If you still remember, F equals to phi R. This is F. And F is due to the number of turns times the current. So what is F? F is the magnetomotive force, the force generated due to the movement of the magnetic field. And it uses a right-hand rule to determine where is the forces. Let's say the coil is like this. Okay, and then the current go in and go out. So we use go in here. Let's say go in here, go out here. So maybe go in here, go out here. And then we try to use a right-hand rules. Then we found that okay, the force is go to this side, which means this is north, this is south. So this coil will make we call electromagnet, temporarily magnet. If let's say there's no current, the north and south will be nothing. Okay, the north and south will be nothing. And this line we call it as a magnetomotive force. Magnetomotive force. So, and it is a vector. It is a vector. It has a direction. The direction is like in here. Direction. It can be this, this, this. So it rotates in a circle. This is called direction. So first of all, we need to calculate the slot pitch, angle per slot. So 360 divided by how many slots? 3 slots. We have 120 mechanical degree. And then 120 mechanical degree, we can times pole pair. Pole pair, this is 2 pole. 2 by 2 become 120 electrical degree. Calculate it first. Don't need to understand. Calculate it first. Second. Oh, sorry. Up to now, okay or not? Up to now, okay or not? Hello? Up to now, okay or not?
Okay.
Okay, thank you. So step 2, we need to calculate the pole pitch. Pole pitch is the angle per rotor pole. So one angle divided by how many pole? It is 180 mechanical degree. Sorry, I need to go back here. This is 120 mechanical degree, which means it's this one. So from 0 degree, from 0 degree here, and then another slot is here. This one is called 120 mechanical degree. Same as well here. 120 mechanical degree. 120 mechanical degree. Okay? But when we convert to electrical degree, it is 120. Electrical degree 120, we cannot see from here. We cannot see from here. it cannot represent electrical degree. It only represents mechanical degree. And then we calculate the angle per rotor pole. So which means we use 360 mechanical degree divided by 2. It is 180 mechanical degree. So have a look back. So this is the rotor pole. This is the rotor pole. Let's say this is north, then this is south. North pole is go out, south pole is go in. So this pole, from this pole, it deviates 180 mechanical degree. This is the meaning, right? Then we want to convert to electrical degree times pole pair. So which is electrical degree. Same as well. From here, we cannot see any electrical degree. We cannot see any electrical degree. Okay. So step 3, we need to calculate number of slot per pole and SPP. So 3 divided by 2, it is 1.5, which is less than or equal to 1.5. That's why we have a correspond of, we choose correspond of 1. Then 3 phase, 3 slot double layer. Okay. We want to design the motor 3 phase, then 3 slot 1, 2, 3 double layer like this. So we have a layer 1, layer 2, layer 1, layer 2, layer 1, layer 2. And then what else? Okay, we need to start from, we need to use 3 slot times 2 layer, then divide by 3 phase. It becomes 2 slot per phase. So in order to wind the motor, it must 2 slot per phase for here, which means we have a phase A, we have a phase B, we have a phase C, which is 3 phases, right? We must use 2 slots. So how many slots? Let's say A1, A2 is 1. A1, A2 is phase A. B1, B2 is phase B. C1, C2 is phase C. Okay? So we can see 1 slot, 2 slot. 1 slot, 2 slot. 1 slot, 2 slot. And this is the meaning of 2 slot per phase. Okay? And then we also proceed 1 coil per phase, which means we use 2 slot per phase divided by 2 slot per coil. 2 slot per coil means when we want to coil, when we want to make a coil, it must have a 2 slot. No matter how, from here coil to here or from here coil to here, it must have a 2 slot. Only 1 slot, there's only 1 line. Okay, only 1 line. So when we divide by 2 slot per coil, we know that for 1 phase, it only have a 1 coil. So come back here. 1 phase, only 1 coil. So phase A, 1 coil. Phase B, 1 coil. Phase C, 1 coil. So this is the meaning of 1 coil per phase. This is the 1 coil per phase. Okay? So this is the basic, you need to understand. Or else when you go to in deep one will be confusing. So step 5, we need to put all the information from the top inside this. Now we know that stator coil, how many stator coil that we need to have? 3, right? Because 1, phase A, phase B, and phase C. How many coil we have? Okay. This is a 1 coil per phase. Stator coil. Oh, stator coil is a stator slot, sorry. Stator coil is the stator slot, is it? Let me think. I forgot this stator coil, stator slot. Remember vector for each one determine this one. Forgot the wait, let me see the maybe here. Wait. Let me see. Stator coil. Yeah, this is a 9. Yeah, that's correct. So stator coil is a stator number of stator pole. So we have a 1, 2, 3. Okay, and then this arrow is the meaning. No, this arrow is not meaning here yet. Then MMF vector for each coil. Okay. What is the meaning of MMF for each coil? Which means we know that we will coil like this. Then we will coil like this. then we will coil like this. No matter how when we excite the current, there will be a force. This one will become a electromagnet, which is go up, go like this, or go inside. This one also same. If let's say it excite counterclockwise, it become like this. If let's say it excite another one, it become like this. Same as well. When it excite like this, when it excite, it become like this. So this one is so-called MMF vector. It can be go in or go out, but it cannot be like this, huh? It cannot be like this or like this, because when we coil like this, when we give the current, it will only either here, either here. Same as well, either go in, either go out. It depends on either we give a positive clockwise or counterclockwise current. Okay, so the first thing is we need to record the MMF vector for each coil in electrical degree. Okay, how to do that is usually we start from 0 and then we just top up what? Top up this value, top up this value. So 120, right? So when we start from 0, then we add up, become 120. Okay, then we add up again, become 240. If let's say it is not 3 slot, it is 4, 5, 6. Okay, we add up again, become 240 plus 120 become 360, right? So 360 it start from 0. So 0 it add up again, 120 become 120. 120 add up again become 240. It's something like this. Okay or not? And then we need to determine which is the initial phase. So usually in initial phase, if you still remember the 208 three-phase system, A is from 0, okay, B is from 120, C is 240, something like this. That's why we will go to search where is the electrical degree, give us 0. So this one give us 0. So we use so many things. So this coil give us 0. This one give us 0. So I will take this as a initial value. And then this one is 120. I'll take B as a B, 240 as a C. So this step settled. And then we need to refer radar, draw stator line, draw MMF vector, list the slot number, and state the initial phase. Have a look, huh? So now I want to take out everything. Okay. First of all, when we want to translate the step 5 to this radar, we call this one is called radar, radar. Then first of all, it stated that we need to draw the stator line. So stator line is actually the MMF vector created by this one. Usually we always assume out first. We always assume out first. So for here, this one will be F1. This one will be, sorry, this is a stator line, sorry. Stator line. Alright, this is stator line. The line here, here, here. Next, we need to draw the MMF vector. So MMF vector is something like when we know that this is the coil. Okay, when we know that this is the coil, okay, we usually refer to outside first. We refer the MMF go outside first. So this is so-called MMF go outside. F1 is this one 1. 1 is because of truth number 1 or slot number 1. Usually I will refer this one slot number 1. This is slot 2, slot 3. This is slot 1, slot 2, slot 3, which is same. So this is represent slot 1. This is represent slot 2. This is represent slot 3. And then refer to here because counterclockwise is the default area. So the field, the MMF vector also become F1. So F1 is here, then F2 is here, then F3 is here. So this is the step we need to follow first. After that, we need to list slot number. So I list the slot number. This is a slot 1 for here, slot 2 for here, slot 3 for here. So slot 1, slot 2, slot 3. This one, okay, maybe I need to delete so many things. this one is equal to this one. So this one is equal to this one. This one is equal to this one. Same as well for here lah. We can use this one is equal to this one. Same same. So you can see that later I show you lah. Same is same Then we state the initial phase. So this is the initial phase lah. We already state the initial phase here. After that, we need to choose the coil per phase. Choosing here will be a little bit different. We have a reverse polarity. We have a forward polarity. Which coil? We know that we only need one coil per phase. Okay. So this is represent phase A. Here is all phase A. This phase B. Then this one is a phase C. And then for each phase, for one phase, we have a one coil. One phase, one coil. One phase, one coil. One phase, one coil. Okay? And then, now we want to ask ourselves is how can we coil from which slot to which slot? So that's the problem now. Let me see. Yeah, I think we list out everything. So let me take a picture first. Okay. So now we choose F1 as a phase A. So I will take F1 first. Then I choose F2 as a phase B. So I take F2. Then we choose F3 as a phase C. So we write FC. Okay, that's it. Finish. I mean, finish from the interrelationship. And now we need to directly convert F1 becomes slot number 1. Same as well, F2, slot number 2. F3, slot number 3. Okay, and then when we slot number 1, we will rewrite become A. Oh, too many things. Okay, we will rewrite A1 plus B1 plus C1 plus. Okay, so how we coil is we need to add up our corresponding number as we calculated as above, which is correspond is 1. So A1, this one S1, it will plus 1 become S2 as a forward polarity. Forward means it will go out. If let's say reverse, it will go in. For example here, this one is called forward. Then we can counter it become reverse. When we come to other itu panggil apa? Example, then I will tell you where is the reverse. Now we do the forward polarity first. So S2 plus 1 become S3. And then S3 plus 1 become S4. But the problem is we only have a S3 the maximum. So what we can do is we minus the maximum value. So 4 minus 3 become 1. Okay? Then we need to rename A1 minus B1 minus C1 minus. This is how we get the A1 plus, A1 minus, B1 plus, B1 minus, and then C1 plus, C1 minus. After that, we need to draw the winding layout. So have a check. A1 plus to A1 minus is from S1 to S2. So have a check. A1 plus is from S1 to S2. So S1 to S2. Sorry, let me finish this one. S1 to S2. So A1 plus to A1 minus. Alright. So next, S2 to S3 is B1 plus to B1 minus. S2 to S3 B1 plus to B1 minus. Plus mean is go in, the current is go inside, then minus is go outside. For example, so you can use a right hand rules. Right hand rules. The four fingers will go into the A1 plus, okay, then come out to A1 minus. Then we will see the F1 is go up. This is called forward polarity lah. So B1 as well. Go when we use the right hand rules, the A forward polarity. Then another one is S3 to S1. S3 to S1 becomes C1 plus C1 minus. So S3 to S1, C1 plus C1 minus. Also forward polarity. If let's say we design wrongly, let's say this one maintain, suddenly we put A1 minus, A1 plus here. So the polarity that we chosen is become like this, F1. By using right hand rule. It becomes like this. So the overall vector become like this. Then this kind of motor will be wrongly designed. So that's why from this simple one, we know that okay, A1 plus A1 minus, B1 plus B1 minus, C1 plus C1 minus. It's for sure it's very easy. But what if you have we have a lot of slot number? Then will become very difficult. So okay, so this is the how we do the winding layout lah. I'm not sure whether do you want to proceed for second example or not, or you want to stop here. Do you want to proceed second example or you want to stop here? Stop here. Okay, can. So we continue next week lah. We have a lot of example that I need to bring through you lah. For here, for example, 3, 2, 6, 4, 9, 4, 9, 6, 9, 8, 9, 10, 12, 4, 12, 8. We have a lot. Maybe I will choose maybe several only lah. Several, maybe 3 to 4, then to explain. So I guess I stop here. I want to ask, do you have any questions?